A very good morning to all of you. So today we will try to understand some numericals on the single phase, three phase fully controlled rectifier, then dual converter and chopper. So we'll take this numerical. So as you can see that we are having a DC motor and that DC motor is separately excited. It means that the armature and field winding are separated. So a 200 volt DC motor you can see here and the RPM that is 875 RPM. Then this is the rated current. So the rated values are given in the problem, and this DC motor will be having the armature resistance of 0.06 ohm. So it is fed from the single phase fully controlled rectifier with an AC voltage of 220 volt 50 hertz. Fine. So everything is given and you will have to assume the continuous conduction. So basically we'll start with the rated values only. So when voltage is given and you are having the RPM, that is the RPM, so you can easily calculate the electrical equivalent. Now how to calculate the electrical equivalent? So first step is that whenever the rated values are given in the problem, you calculate the back EMF for that rated values. So in that case, this one will be E1 will be equals to what? So this one is VA, that is the armature voltage. Then you are having this as N. Then this is IA, that is 150 ampere, because we have because it is given that the motor is separately excited. This is the armature winding. So armature winding will be having will be taking the current of IA, and the armature resistance of RA will be equal to 0.06. So I think everything is given here. So how to start with? So like I mentioned that you will have to calculate this E1. So this is for the rated one. So now if you just put down all the values, I think it is 200 minus what? Minus IA into RA. So IA is 150 and 0.06. So suppose if you just calculate this thing, then you are going to have this value, that is 191. So E1 will be equals to 191 volt, because this is the motor, and you know that the back EMF is always lower as compared to the armature voltage for a motoring mode. If you want to operate your motor in the forward motoring mode, then the back EMF is less than the armature voltage. Now, this is the E1 which you have calculated. So, E1 is there. So, now you will have to calculate the firing angle for a rated motor torque. Now, this thing you will have to keep in mind that whenever we talk about the rated motor torque, it means that the current is rated, because T will be equals to what? K into phi into IA. So, when the torque is rated, current is rated. So it means that you will have to take this current. Even for this condition, your current will not change. So the new IA2 value will be the same with the previous IA2 IA value. So IA2 will be equals to IA will be equals to what? 150 ampere. Now you will have to calculate the firing angle. Now how to calculate the firing angle? So for that you need to calculate, because if you want to calculate the firing angle, it means that the output voltage has changed, because the current you can see here the formula is what? I will be is equals to V minus E upon RA. You are maintaining the current constant. So when the current is constant, it means what? Your back EMF and this voltage is going to change. Armature, this RA will be a constant value. It is not going to change with time or by changing anything. So suppose if you want to calculate, suppose if your speed has changed, it means that both the armature voltage and the back EMF has changed. So you will have to calculate both this E also and this armature voltage. Only then you will be able to calculate the firing angle. Because for single phase, what is the value of armature voltage? It is VA will be equals to twice into, it is VA will be equals to what? VA will be equals to twice into Vm upon pi into cos of alpha. So by this formula, you can easily calculate the alpha value. So I think everything is clear now. So how to start with this? So for a rated motor torque, IA2 is equals to IA, that is 150 ampere. So now you have to go for firing angle. So how to start with? First, you will have to calculate the value of E. Then accordingly, you will calculate the value of V. Then you will have to calculate the value of alpha. So first, E is the priority. Now, how to go for this? So we know that E will be equals to what? K phi into omega m. So E will be is equals to K phi into. Now this is the angular speed. Now the speed here it is given in the revolutions per minute. So you need to insert, you need to incorporate that. You need to take this n value. So 2 pi n upon 60. So in that case, E will be is equals to K phi into n. Everything is constant. This phi is also constant because it is separately excited. So we have introduced the n value, that is the speed, which is in the RPM. So now with this relation, you can easily calculate the back EMF for the new speed, because you know that when the speed is changed, it means that the electrical equivalent is also going to change. So in that case, E2 upon E1 will be equals to what? N2 upon N1. So E2 will be equals to what? Because we are solving for this first condition, no? So E2 will be equals to E1 into N2 upon N1. So I think E1 is already calculated for the rated motor torque, na? For the rated values. So E1 will be equals to what? 191 into. Now, if you just put down all the values, then I think it is 750 RPM. That is the new speed. This is the new speed, and this is the previous speed. We can say. Then 875. So I think accordingly, if you solve, then E2 will be equals to what? E2 will be equals to, if you just solve the values, so this comes out to be 163.71 volt. So I think E2 is now evaluated. Now, how to go for the armature voltage? Now, the armature voltage means what? That is, this is the armature. This is the armature. Let us say this is the armature. This is the armature. Fine. So to this you are feeding what? The armature voltage. That is VA. So if you want to apply, if you are applying a KVL here, so VA will be equals to what? E plus IA into RA. Fine. Is it okay? So now we want VA2. So VA2 will be equals to A2 plus IA2 into RA. You have just calculated the back EMF for a new speed. So E2 will be equals to 163.71. Then IA2 value, right, because the same motor torque, rated motor torque, the torque has not changed. So IA2 will be equals to 150 into 0.06. That is the armature resistance. So if you just put down all the values and calculate the things, then you are going to have what? VA2 will be equals to it is how much? I think one I am having the answers with me, 172.71. So now VA2 will be equals to 2 Vm upon pi into cos of alpha. Now you can see that this is fed from the single phase fully controlled rectifier with an AC voltage of 220 volt. So this is Vm, this is the peak value, and this is the RMS value. It means that you will have to convert this RMS value into other peak value. So how to convert? Then this is 172.71. This is 2 into 220 into root 2 upon pi into cos of alpha. I think the things are very clear to you. So the cos alpha will be equals to some value, and alpha will be equals to, you are going to have the value. I think we'll check it out in the PDF itself. I think in the PDF itself you are having the value. This is alpha will be equal to, you can see, 29.31. So if you if the firing angle is 29.31, then in that case you are going to achieve this 750 RPM. This is for the motoring operation. Now, similarly, you will have to calculate the firing angle for the rated motor torque at minus 500 RPM. Now, you can see here the torque is again a constant. The torque is constant. So, torque is constant means what? IA3 will be equal to, now here, IA3 will be equals to IA. IA3 will be equal to the same torque is there, no? The same torque is there. So Ia3 will be equals to Ia. So, and this is the minus 500 RPM. So how to solve? Now the next N3 will be equals to minus 500 RPM. Rest everything will be same. Everything will be same. So again, if you want to calculate the firing angle, now how to go for this condition? First, you will have to calculate the back EMF. After calculating the back EMF, then you will have to evaluate the armature voltage. And accordingly, when you get the armature voltage, then you can easily calculate the firing angle. So in this way you can do the things. So we'll just move down to this. You just have, now you can see here the rated torque. The rated torque is the same thing because you will have to find the firing angle for the rated torque. The torque has not changed. Torque and the value of the torque has not changed. Now you can see there here the N3 is minus 500 RPM. So first we have calculated this back in for this speed. That is the electrical equivalent now. So after that, VA3 will be equals to E3 plus IA3 into RE. Now you can see here the back EMF is has reverse. So this is the breaking one. Fine. So we have just put down the values here, and you can easily and you can see here VA3 will be equals to minus 100.14. Now similarly, just 2 Vm upon pi into cos alpha. So if you just put down the values, you are going to get the alpha will be equals to 120.36. And I have told you in my theory classes that if you keep alpha less than 90-degree for single phase full wave control rectifier, then you are going to have the power, then you are going to have the positive power. Now if you keep alpha greater than 90-degree, and the power will be negative. It means that the power which has been stored in the will supplied back to the source. So this is the breaking one. Now next bit is what? Third condition. Third condition is motor speed for alpha will be equal to 160-degree and rated torque. The torque is again, you can see the torque is constant for all the three conditions. So in this, IA4 will be equals to IA only. And now here alpha is known. Alpha is now known to us. Fine. Alpha is not known to us, and you will have to calculate the motor speed. So you just have to go in the reverse fashion. First, when the alpha is known to you, then what you are going to calculate? Right, when alpha is known to you, so you can just calculate the VA, that is the armature voltage. So armature voltage VA will be equals to how much? Anyone? So VA will be equals to 2 Vm by pi into cos alpha. So we will just calculate the things for this condition. So the first one will be VA4, right? I'll just write the things. VA4 will be equals to twice Vm upon pi into cos of alpha. Now, the Vm is known to you because this is the RMS value. Then 2 into 220 into root 2 upon pi. This is cos of 160-degree. Fine. Then, after calculating the thing, then this is minus 186.12 V. Fine. Now, VA will be equals to how much? Now, after finding the VA, now the next step is to find the E. So, VA4 will be equals to VA4 will be equals to E4 then plus RA 4 into RA. Now E4 will be equals to VA4 minus IA4 into RA. So VA4 means how much? That is 186.12. It is in volts only, now. It is in volts. Now minus IA4. IA4 means what? That rated torque. Rated torque IA4 will be equals to IA. The torque has not reduced to half, or it has not doubled. So we take IA will be equals to 150 ampere. So you just have to put down the values. That is 150 into 0.06. So what is the value? Minus 186. Let me just check with my answer. Let me just check my answer. That is, I think it is minus 195.12. Fine. So once you evaluate once you have evaluated the back EMF, so now you can go for the speed. So the speed means what? I am writing here. Let's have a look. I am writing here. So E4 will be equals to what? N4 upon, because E is proportional to N. So N4 upon what? N4 upon N1. Now you have to take the initial state. Our initial state is the rated state. N4 into, so this one is E1. Fine. So N4 upon N1. N4 means what? Right, that we will have to calculate. E4 it is given to you, E4 is known to you, then N4 you have to evaluate, N1 into E1. So you write in this way, N4 will be equals to E4 into N1 upon E1. I think somewhere, right, this is okay. E4 into N1 upon E1. So if you just put down all the values, then what you are going to get? E4 will be minus 195.12, just evaluated, and E1 will be what? That is 191, na? Uh, in the 191 into N1 875, N1, this is N1, this is N1. So N4 will be equals to, this is minus 893. I think 893.7 RPM. So in this way, 8.2 RPM. In this way, you can solve this question. So now you can go for a second question also. Now in the second question, what is given, you can see here. The second question, everything is same. Fine, everything is same. But you will have to calculate the firing angle for half the rated motor torque. When I'm saying half the rated motor torque, it means that this is the rated current and this is half the rated motor torque. It means that you will have to half your armature current. You will have to make your armature current to a half value. So in this case, IA2 will be equals to what? IA2 will be equals to 5 ampere. Fine. IA2 will be equals to 5 ampere. Everything is given, you know. VA is 220 volt, then this is speed, this is IA, fine, and this is the AC source voltage. By using the AC source voltage, then we are having the rectifier, or you can say a control rectifier. So this is going to give you the alpha value, fine. So I think you can solve the questions on single phase control rectifier fed DC drive. This is all for this class. We'll meet in the next class for three-phase fully controlled rectifier.